plus b squared equals c squared. Plug in your values. Square root of 6 squared plus the square root of 7 squared equals the square root of 13 squared. Now, when you have a square root and a square around the same number, they're inverses of each other. So once you do one, the other one undoes the first one. It's kind of like multiplying by 2 and then dividing by 2, because they're inverse of each other. They kind of cancel out in a way. So the square root of 6 squared is just 6. Square root of 7 squared is just 7. Square root of 13 squared is just 13. 6 plus 7 is 13. 13 does equal 13. Therefore, yes, it's a right triangle. Let's show you an example where the triangle may look like a right triangle, but in fact it is not, after we prove it using the converse. So in this case, we have 13 square root of 161 and 15 feet. If there were going to be a candidate for a 90-degree angle, it would be right here, which would then make your 15 a possible C value, and 13 A and B. And if you plug them into the equation for Pythagorean theorem, you have 13 squared plus the square root of 161 squared equal to 15 squared. 13 squared is 169. As we said before, the square root of 161 squared is going to be 161. 15 squared is 225. Now if I add the two left numbers, 169 plus 161, that's going to be 330, which clearly is not equal to 225. So therefore, it's a false statement, making this not a right triangle. So if the statement is true, it is a right triangle. If the statement is not true, it is not a right triangle. There's one more skill that I want to talk about in this video, and it is squaring a number like 4 root 3. There are two factors there. So within this equation, a squared plus b squared equals c squared, we know how to set it up, plug numbers in, calculate and see if the two sides are equal to see if it's a right triangle. However, with a value of 4 root 3, you have two numbers to think about. 4 root 3, that entire thing gets squared. Not just 4, not just root 3, but both get squared. B is going to be 11 squared, and C is going to be 13 squared. Now, like I was saying before, the 4 gets squared, as well as the square root of 3 gets squared. Most common mistake students make is that they apply the square root as one or the other, but not both. So 4 squared is 16 times the square root of 3 squared, which is just 3. So we have 16 times 3, which is 48, plus 121 equals 169. Now when you add these two numbers together here, it does end up being a right triangle. So you answer this, yes, it is a right triangle. But I just wanted to show you what that looks like, that calculation. You square both the 4 and the root 3, and you get 16 times 3, which is 48. So we have talked about finding missing side lengths with Pythagorean theorem, solving for A, B, or C, isolating the variable, square rooting to cancel out with this power of 2. And then we did the converse. We found out if a three side lengths given to you, whether it represents a right triangle, yes or no. If it is a true statement at the end, like up here, 100 equals 100, then yes, it is a right triangle because the sum of the squares of the legs is equivalent to the square of the hypotenuse. Over here, this example, the sum of the squares is equal to 330. The square of the hypotenuse is 225. Clearly they don't equal. So therefore it's not a right triangle. It's still a triangle, but it's not a right triangle.